So guys, let us start with a new chapter today, which is limits. Now, what exactly is the meaning of the word limit? In general, I can say that the meaning of the word limit is something called as restriction. You are applying a limit to a certain value, it means that you are applying a restriction to a certain value. Now, what kind of restriction it can be? When we are talking about a certain function, we need to use the limit so that we can understand whether the value of that particular function or value of that particular variable satisfies the given function or not. So how do I understand whether it is getting satisfied with the function or not? So it's very easy. Let us understand this with an example. As I told you, the basic idea about the limit is nothing but a restriction. So I will write over here restriction on value of a variable. So what does it mean? Suppose if I have an example, let us say fx is equal to x square minus 4 upon x minus 2. And suppose if I try for different values of the variable x, let me consider x is 0, 1, 2, 3, minus 1, minus 2, and minus 3. For different values of x, I have different values of fx. So let us see what is the answer that I will be getting. So now guys, when the value of x is 0, I will get 0 minus 4 divided by 0 minus 2, which is minus 4 upon minus 2, which is going to be equal to 2. Now this 2 is actually a real number, so obviously 0 cannot be a restriction for the value of variable. The variable can definitely be equal to 0. Okay, so guys, the first value that we discussed was 0, so according to which the function value comes out to be equal to 2. Let me try for the next value of x, which is equal to 1. If I consider x is 1, I get 1 square minus 4, which is 1 minus 4 minus 3, and 1 minus 2, which is going to be minus 1, which is equal to, again I can observe that 3 is again a real number. So guys, there is no issues with the value of x to be equal to 1. This also does not have any restriction. 0 and 1, they both are satisfying the function value. If suppose I check for the next value, which is minus 1, I will get minus 1 square, which is 1, and 1 minus 4 will become minus 3. Denominator minus 1 minus 2, that will again become minus 3. So guys, on dividing, I get the answer as 1, which belongs to real number. So this is also acceptable. Suppose if I try for negative 2, so in that case, I will get minus 2 square, that is nothing but 4. 4 minus 4 is 0, denominator 0 upon negative 4. Division by a negative number is acceptable because 0 upon any number is always 0 only. So we will get the answer 0, and 100% 0 is a real number or an integer. So definitely this is a valid answer. But over here guys, if you substitute the value as 2, that is the positive 2, I will get 2 square 4, 4 minus 4 is 0. Denominator is again becoming 0. So guys, in the case when the denominator becomes 0, you know that division by 0 is not possible. 0 cannot be used in the denominator. Because the division by 0 is not possible, so this value over here becomes my required limit of the given function fx. Means this 2 is creating some restriction that I cannot use the value 2 in place of x in this function, because if I consider the value 2, denominator is becoming 0, and if the denominator becomes 0, you know that division by 0 is not possible. Therefore, guys, this 2 becomes a limit, becomes a restriction on the value of x for this particular function. It is like that. In case if I try for a value which is higher than 2, which is 3 in my case over here, so I will get 3 square, that is 9 minus 4, which is equal to 5, as well as for the denominator 3 minus 2, which is equal to 1. So guys, I get the answer as 5, which belongs to real numbers. So again, this 3 does not have any limitation, does not have any restriction. If I use negative 3, I will get 9 minus 4, that is 5, divided by minus 3 minus 2, which is minus 5, which is again minus 1, which also belongs to a real number. So the only problem that was being created when I consider the value of x as 2. So guys, any value of x, any real value of x is acceptable for variable x in this function other than 2, because this 2 over here is a limit, it is a restriction, it is a limitation of the variable x for this function. So guys, this is the basic meaning of the word limit. Like, what is the restriction on the value of x for the given function? Now, what I did just now is to explain to you the concept of limit, guys. You don't have to do this in your actual examples. You will be given what is the limit value. You just have to substitute and you have to check whether it is getting satisfied. Sorry, it is not getting satisfied. So in order to do that, there are some basic types of functions that we need to know, we need to understand. So I will explain you the different types of functions first of all that we are going to see in this particular chapter. And after looking at those functions, I will go on with the first, second, and the third exercise and so on. Okay. So please write it along with me. The first one that you have is algebraic function, or you can also call it as polynomial function. The basic idea to identify the polynomial function is like this. There should be a variable in the base and any constant number in the power. The constant number can be positive, negative, fraction, decimal. It can be anything. Everything is acceptable for the variable value x in this particular case. Okay. If I take an example for this, I can have x square plus 2x minus 1. It can be 2x plus 1 divided by 5x minus 2. I can take the above function that I had taken, x square minus 4 upon x minus 2. So guys, these are all the various polynomial functions with which we will be solving in our examples. I will explain to you how we have to solve the questions. But in order to solve the questions, we should know the type of function first of all. So remember guys, whenever you come across any polynomial, it is always considered as an algebraic function or a polynomial function. And this is the basic idea to identify that the variable is in the base and the constant number over there is in the top. This is the first one. Now let us see the second one. The second one that you have is the exponential function. Now, what is an exponential function? It is guys just exactly opposite of the algebraic function. The difference between these both is that the constant number goes in the base and the variable over there goes in the power. So if I have a constant raised to variable, then in that case it is called as an exponential function. If I take an example for this, It is 7 raised to 3x, 3 raised to minus x, e to the power 4x, 6 raised to 2 by 5x. It can be anything. Guys, in case if you are not having an idea about e, what is this e? E over here is called as an exponential constant, and it is an irrational number like pi. Just as you know that pi has a value 22 by 7 or it is equal to 3.14, e also has its own fixed value, it is 2.7182. This is a fixed value for the e, which is an exponential constant. Actually, it has a separate name which is called as Euler's constant. It's not necessary for you guys to remember this name, the Euler's constant, but if you remember, it's okay. Even if you don't, it's still okay. But yeah, if you know the value of E, then it's really good for you. Number three, the third one that we have in our syllabus is the logarithmic function. So now guys, what is a logarithmic function? In any question, when we see the word log of 2x, log of 3x minus 1, anything where the word log is used or considered, it is always a logarithmic function. Simple. So now the next thing that you have over here guys is a certain formula for calculation of limits. So just write down this formula please everybody. It is like this: limit as x tends to a, x raised to n minus a raised to n upon x minus a. It is equal to n into a to the power n minus 1. N into a to the power n minus 1. So guys, let us understand how we apply this formula. It's a very, very important formula guys. So please listen carefully. If you have limit as x tends to 4, I will start with a very easy example. Limit as x tends to 4, x raised to 2 minus 4 raised to 2 divided by x minus 4. The only thing that you guys have to do is to compare these both. If you compare, you can understand over here that a seems to be the value 4 and n over here is the value 2. So guys, when you want to apply the formula, the limit, you have to write just two simple words saying it as applying limit. So when you guys say that you are applying limit, it means that we are trying to use the formula whichever is applicable in that particular situation. So what is the formula applicable over here? It is n into a raised to n minus 1. So if you use this, you will get a very easy answer. It is 2 into 4 to the power 2 minus 1, which is directly equal to 1. So if you write the power as 1, it's your choice. If you still don't write the power as 1, it's still okay because writing the power as 1 will not make a very big difference. So it's not an issue over here. So guys, the answer over here comes out to be 4 times 2, which is equal to 8. A very easy example. Example 2. If you have a question like this, limit as x tends to 5, root x minus root 5 upon x minus 5. Still guys, no worries about that. We can convert this in the form of x raised to n by using the formula under root of a in general can be written as a to the power 1 by 2. So if you write it like this, it will become limit as x tends to 5, x raised to half minus 5 raised to half divided by x minus 5. And now if you compare this with the general formula over here, I can identify that a value is 5, but this time n value is 1 by 2. Whatever is there in the power is 1 by is n. So n is half and the base value is equal to 5, which is a. So guys, if I use this value over here, it will become applying limit. So it indicates that I am now going to use my formula, which is half into 5 to the power half minus 1, which is minus half. Now when I want to consider the value of 5 raised to minus half, it is a raised to minus m, which can be written as a raised to m, the laws of indices that you have already studied in your smaller classes. So here it will become half into 1 upon 5 raised to minus 1 by 2. So what is 5 raised to minus 1 by 2? It is going to be equal, it's not 5 raised to minus 1 by 2, sorry, 5 raised to 1 by 2 it will come over here. So in this case, my answer is 1 upon 2 into root of 5. So this becomes our final answer. Let us see one more example and then we'll go with our exercise questions. Example 3. Limit s x tends to 2 x cube minus 2 cube divided by root x minus root 2. Suppose if I come across this kind of a question, just as I did in the previous sum, I will once again do the same thing, the same application over here. X cube minus 2 cube will be left as it is, and root x minus root 2 will be taken as x raised to half minus 2 raised to half. If you observe your general formula, it is like this: x raised to n minus a raised to n upon x minus a, which has the answer n into a to the power n minus 1. Now in this sum, guys, the problem is that the numerator is x cube minus 2 cube, which is representing x raised to n minus a raised to. Denominator is x raised to half minus 2 raised to half, which is also representing the same element, which is x raised to n minus a raised to n. So in this case, what about this x minus a? This is not available in the question. So does it mean that the question is wrong? Absolutely not. The question is absolutely correct, and this step what we have done is also absolutely correct. When a certain element or a certain part is missing, we can ourselves bring it out in the question by using the property of multiplication and division of the factors or the fractions. So whenever a certain fraction is multiplied or divided by a same number, its value does not change, but it helps you in the working. How does it help us? Let us see. I will write over here. Divide numerator and denominator by x minus 2. Why x minus 2? Because I want x minus a, and I can see over here that a is 2. Therefore, I take x minus 2. In any other question in your textbook, if you see the value limit x tends to 3, then in that case you will have to say dividing numerator and denominator by x minus 3. Okay? So here I will get this is equal to limit as x tends to x cube minus 2 cube upon x minus 2 whole upon x raised to half minus 2 raised to half upon x minus 2. Now guys, this is in the standard form as well as both of them in the numerator and denominator expressed in the standard form. So now when I want to find the answer, as usual, I will say over here, apply limit, and I will apply the formula in the numerator and in the denominator separately. So just see very carefully how I do it. The numerator will become 3 into 2 to the power 3 minus 1 divided by half into 2 to the power half minus 1. So guys, this over here, denominator 1 by 2, it will become reciprocal and get multiplied with 3. So I will get the value as 6. And this will become 2 square divided by 2 raised to half minus 1 is nothing but 2 to the power minus half. And therefore, if I transfer this in the numerator, it will become 2 to the power positive half. 6 into 4 into 2 raised to half, which becomes 24 root 2 as your required solution. Okay, so let us see the first question of our first exercise. It's very easy question over here. In this case, you are given limit as x tends to 3 divided by, in fact, applied to under root of x plus 6 upon x. So let us see what we can do in this. It's one of the easiest sums of this exercise. You will get divided by 3. Now in this case, if you observe, it is not representing any standard formula, it is not representing anything. So in this case, when I come across this kind of a question where there is no standard formula applicable, just I have to substitute the limit value in the given function and simplify that. So when you want to substitute the limit value, I told you that you have to write just two simple words saying that apply limit. The meaning of the word apply limit is that substitute the value of x as the given limit value, which is 3 in this case. So when you substitute this, you will get under root of 9 divided by 3, which becomes 3 by 3 ultimately, which is equal to 1. A very simple question. You just have to substitute the limit value and you get your solution. Number 2. The second question over here says limit x tends to 2, x raised to minus 3 minus 2 raised to minus 3 upon x minus 2. X to the power negative 3 minus 2 to the power negative 3 divided by x minus 2. So guys, working is exactly same as we had done in our previous questions. I will remember my formula. The formula is limit as x tends to a, x raised to n minus a raised to n upon x minus a, and the answer is n into a to the power n minus 1. So here, what is the value of a and what is the value of n? I'm sure everybody must have got it by now. A is 2 and n is the power, which is negative 3. So guys, it is exactly as per our requirement in the standard function, in the standard formula. So you just have to write two simple words and go with the solution. So you will get, or you will write over here, applying limit or just apply limit, and it says it is n into a, which is minus 3 into 2 to the power minus 3 minus 1, which is minus 3 multiplied by 2 raised to minus 4 I can write minus 3 upon 2 raised to 4 just to make the power as a positive number. I took that in the denominator. So my final answer is minus 3 upon 2 raised to 4 is 16. So the solution is, or the answer is, or the limit of the function is negative 3 upon 16. Very easy sum it is. Let us see the next question. Limit as x tends to 5, x cube minus 125 divided by x raised to 5 minus 3125. So again, it's a similar sum I did just now for you guys. Limit as x tends to 5, x cube minus 125, x raised to 5 minus 3125. I can express the given question by writing it like this. X cube minus 5 cube divided by x raised to 5 minus 5 raised to 5, because 5 raised to 3 is 125 and 5 raised to 5 is 3125. Therefore, I am writing it like this. So guys, if once again I write my formula x raised to n minus a raised to n upon x minus a, I can just understand over here that the numerator x cube minus 5 cube is expressed in the form of x raised to n minus a raised to n, as well as this number x raised to 5 minus 5 raised to 5 is expressed in the same format x raised to n minus a raised to n. But this is something which is missing, without which I cannot apply my formula, I cannot apply my solution. Very nice. You have to divide the numerator and denominator by x minus 5 in this case, because you got it very right. A value is 5 in this sum. So the solution or the step that I should get should be like this. X cube minus 5 cube upon x minus 5 for the numerator, whole upon x raised to 5 minus 5 raised to 5 upon x minus 5. So now guys, the numerator and the denominator will be applied with the formula separately. In both the cases, a is 5, but n has got different values. Numerator, the power value is 3, therefore n is 3. Denominator, the power value is 5, therefore n is 5. So guys, when you apply limit in this sum, what do you get? It will be 3 into 5 raised to 2 divided by 5 into 5 raised to 5 minus 1, that is 4. So here I can just cancel off these both numbers, it becomes 5 square. So the answer comes out to be equal to 3 upon 125. So what should we do in this particular case? Let's understand. The left hand side as well as the right hand side, both sides you have to apply the same formula. On the left hand side you are given x raised to 4 minus 1. I can consider it to be 1 raised to 4 because any number in the power 1 does not make any difference to it. Therefore, on the left hand side, I have to write over here, apply limit. So this will become 4 into 1 to the power 4 minus 1 divided by 3 into a to the power 3 minus. In both the sides, I am using the same formula. Limit as x tends to a, x raised to n minus a raised to n upon x minus a. is equal to n into a to the power n minus 1. Guys, always make it a habit to write the formula at least once with all the examples that you are solving and practicing, so that during the exams it won't be difficult for you to identify which formula had been applied when we were studying. So when you are referring these all sums and examples during your exams, you can easily get the question and the applicable formula side by side. So it's a very good practice for you when you are applying or solving the maths problems. Okay, so always try to make a habit like this. Example and side by side write the formula so it becomes easy for us. So this becomes 4 is equal to 3a square. Take this 3 in the denominator. So you will get 4 upon 3 is equal to a square. Therefore, when you take square root, आपको a का वैल्यू मिलेगा प्लस और माइनस 2 by root 3. So there are two values of x, guys, positive 2 by root 3 or negative 2 by root 3. That's why he has told us to find all the possible values of a in this.